Hey folks, 6.1 practice, day 2 here. Let's go through that together. No assignment today, but I do want you to go through it with me. So if you have your work from yesterday, 6.1 practice, we're going to go through the problems right now. All right, here we go. 6.1 for the use after lesson 6.1. Okay, trying to get a little bit better on my writing here. Still a little learning curve. I might have to do some switching around. So bear with me, will you please? So we're going to start with number 1. Square root of 44. Apologize ahead of time. Square root of 44. Now we're trying to use perfect squares. Okay, so if we could find a perfect square like 4, we have a 4 times 11. All right, so square root of 4 times 11 is the same as the square root of 4, which is 2. Okay, so that's 2. And that is the square root of 11. So you end up with 2 square root of 11. Number 2, negative 175. Negative 175 is 25 times 7. Okay, so it's the negative of square root of 25 times the square root of 7. All right, which is negative 5 square root of 7. Moving on to number 3. Negative square root of 10 over 49. Okay, negative 10 over 49, which would be, okay, so this is the division, numerator and denominator. So if you take the square root, you actually have the square root of the numerator, 10, negative square root of 10, over the square root of 49. And that is the negative square root of 10 over 7. Over 7. Number 4, the square root of 54 over the square root of 81. The square root of 54 over the square root of 81. Okay, the square root of 81 is 9, perfect square. Okay, I'm going to go to the right here, then come back down. So that's 9. And the square root of 54, if you think of 54, you think of 9 times 6. The square root of 9 times the square root of 6. And the square root of 9 is 3. And the square root of 9 times 6 is 54. So 9, the square root of 9 is 3. And you have the square root of 6. And that's all over 9. Now, look to simplify. So the 3 and the 9 cancel. So 3 and the 9 cancel. We have square root of 6 over 3. Square root of 6 over 3 as your answer for number 4. Looking for our perfect squares. All right, then we're going to simplify some expressions here. 8 minus the square root of 112 over 4. Okay, this is the same as 8 over 4. Okay, so if I break this up, this is 8 over 4. And I'm going to subtract the square root of 112 over 4. Okay, so if I break that up, this is going to be 2. Okay, now 112. 112 is 16 times 7. Okay, so square root of 16. And that's times the square root of 7. Okay, is 112. And that is over 4. So we're looking for that perfect square again. If we can get that perfect square at 16, that works out great. So we're simplifying using our perfect squares in this section. Square root of 16 is 4. Over this times the square root of 7, all over 4. And then your final answer is going to be 2 minus 4's cancel, square root of 7. And that'd be your answer. Two minus the square root of 7. So looking back at this, breaking 112 down to 16 times 7, looking for that perfect square with that example there. All right, then number 6. I'm just going to put a little line through here, get us going. All right, number 6. Here we have, again, negative 6 over 18. Negative 6 over 18. And you can see that that's going to simplify into negative 1/3. And we have plus square root of 72 over 18. Square root of 72 over 18. Okay, so 72 is 9 times 8. 9 times 8. Okay, 9 times 8. And you can also break that down into 36 times 2. Okay, so 36 times 2. So think of your perfect square there of 36. Square root of 36 times the square root of 2 would be 72. And that's going to be all over 18. Okay, so we already broke down this part. Negative 6 over 18 is negative 1/3. And now we're working on this left side here, or right side, square root of 72 over 18. Okay, so this is 6 now. And if this becomes 6, I'm going to cross it off and go 6. Square root of 36 is 6. Now, if we can simplify this 6 and this 18, because we have a common factor, cross the 6 off and the 18 and make it a 3. So we could combine them again. Negative 1 plus square root of 2, and all of it is over 3 would be your answer for number 6. Okay, so to recap this one, if I work on the left side first, that simplifies to negative 1/3. And then the right side is the square root of 72 over 18. The square root of 72 is the square root of 36 times the square root of 2. The square root of 36 is 6. 6 cancels with the 18, and you have 3 in the denominator. Square root of 2 is in the numerator. All right, lastly on this page is number 7. 36 is the square root of, so if you had to break this out, you would have the square root of 36, which is 6, and times x, square root of x, times the square root of y squared. Okay, so if we broke it out like that, using our key point from yesterday, and you know, as you get comfortable with simplifying square roots, you'll just go right to this. 6, you see the 36, 6, and you also see that you have your 2 y's here. So it'd be y on the outside, and on the inside you'd have your x. Likewise with 50, you're probably going to see that that is 25, square root of 25, times the square root of 2, times the square root of x squared, times the square root of y, times the square root of z squared times the square root of z. Okay, well, square root of 25 is 5. The square root of x squared is x. So if you look at it that way, you've got that out of there, and the square root of x squared is out of there. And you notice you have a z, square root of z squared. You have a z. And so you end up with the square root of 2. You have a y, and you have a z. So 5xz times the square root of 2, 5xz times the square root of 2yz. And that'd be number 8. And finally, on 6.1 practice today is a word problem. A trampoline has an area of 49 pi square feet. What is the diameter of the trampoline? Okay, so the way I work this problem, I first thought of area of a trampoline. And we're assuming it's a circular trampoline. The area is 49 pi. Okay, so that's 49 pi. So the area of a circle is pi times r squared. Pi times r squared. And that's equal to 49 pi. So we were told that the trampoline was 49 pi, and we are asking for the diameter. So if you can see how we divide by pi first on both sides, and you cancel those out and cancel that out. You end up with r squared, which is the radius squared, is equal to 49. And to undo the squaring of r, you take the square root of r squared on both sides, square root, and that number r becomes 7. And it's the positive 7. Now that's the radius, so they're looking for the diameter. So it's only halfway, so the diameter of the trampoline will be 14. I hope that answers a lot of your questions with regards to 6.1 practice. And I think the format was a little bit better today. Got a little kind of scrunched up in a couple spots. So, but keep your eye on perfect squares. We also get into the prime factorization method. We'll do that a little bit later. But we're just trying to work on our perfect squares on this review 6.1 practice A. And that concludes the recording today. Just make sure you get your attendance through Skyward. Make sure you keep working on that on a daily basis. And hopefully you got access to this a lot quicker and easier today. And have a great day, and take care. See you soon.